value 2 represents a quantity. It signifies a count of 2 items, units, or entities. The concept of 2 is fundamental in mathematics and is used across various disciplines to represent a specific amount. 2 is the number following 1m preceding 3. It is the smallest even prime number. In arithmetic, 2 plays a crucial role in addition, subtraction, multiplication, and division. Adding 2 to any number increases that number by 2 units. Subtracting 2 from any number decreases that number by 2 units. Multiplying any number by 2 doubles its value. Dividing any even number by 2 yields a whole number. In set theory, a set with 2 elements is referred to as a pair. Pairs are fundamental in many mathematical constructions and applications. In geometry, 2 is associated with lines and planes. 2 points define a line, and 3 non-colony points define a plane. Two-dimensional shapes such as rectangles and circles are described using 2 dimensions, length and width, or radius respectively. In computer science, 2 is the base of the binary number system. The binary system uses only 2 digits 0 and 1 to represent all numbers. This system is the foundation of all digital computers and digital logic. The binary system is essential for representing data and instructions in a way that computers can understand and process. In statistics, 2 can represent the sample size, the number of groups being compared, or the degrees of freedom in certain statistical tests. Understanding the role of 2 in statistics is crucial for interpreting data and drawing valid conclusions. In physics, 2 appears in many equations and formulas. For example, the kinetic energy of an object is given by 1/2 multiplied by mass multiplied by velocity squared, where the exponent 2 indicates that the velocity is squared. The value 2 also appears in the formula for the area of a circle, which is pi multiplied by the radius squared. In chemistry, 2 is used to represent the number of atoms in diatomic molecules, such as oxygen, which is 2. It also appears in chemical formulas and equations to represent the number of moles or molecules of a particular substance. In finance, 2 can represent a factor in calculating interest rates, returns on investments, or financial ratios. For example, the rule of 72, which is used to estimate the number of years it takes for an investment to double, involves dividing 72 by the interest rate, but the core idea is about exponential growth relating to the number 2 in its principle. In engineering, 2 appears in various calculations related to stress, strain, and structural analysis. For example, the second moment of area, also known as the area moment of inertia, is used to determine the resistance of a beam to bending. The value 2 also appears in electrical engineering in calculations related to power and impedance. The numerical value 2 is a fundamental concept that appears in numerous contexts across different fields. Understanding its meaning and applications is essential for problem solving and critical thinking in various disciplines. The representation of quantities is a core aspect of mathematics and its application to real-world scenarios. The number 2 as a representation of quantity is particularly important in various mathematical operations and concepts. For example, in basic arithmetic, doubling a quantity means multiplying it by 2, and having a quantity means dividing it by 2. These are fundamental operations that rely on the understanding of 2 as a representation of quantity. In algebra, the coefficient 2 in an equation such as 2x equals 6 indicates that the variable x is multiplied by 2, which is a representation of quantity scaling. Similarly, in geometry, the area of a square with side length x is x squared, which means x multiplied by x, representing the quantity of area. In calculus, derivatives and integrals often involve multiplication or division by 2, representing rates of change and accumulations of quantities. Furthermore, the concept of 2 as a representation of quantity is crucial in understanding ratios and proportions. A ratio of 2 to 1 means that one quantity is twice the size of another quantity. This concept is used in various fields such as finance, where ratios are used to analyze financial performance, and in science, where ratios are used to compare the quantities of different substances. The representation of quantities is also essential in statistics. The mean, median, and mode are measures of central tendency that describe the typical value of a set of data. These measures often involve dividing the sum of the data points by the number of data points, which is a representation of quantity. For example, the mean is calculated by summing all the data points and dividing by the number of data points, which is a representation of the quantity of data points. In probability theory, the probability of an event is a number between 0 and 1 that represents the likelihood of that event occurring. Probabilities are often expressed as ratios or percentages, which are representations of quantities. For example, the probability of flipping a fair coin and getting heads is 0.5, which means that the likelihood of getting heads is 50%, representing the quantity of likelihood. In computer science, the binary number system is based on the concept of 2 as a representation of quantity. In the binary system, each digit can be either 0 or 1, representing the absence or presence of a quantity. The binary system is used to represent all data and instructions in a computer, and it is essential for digital logic and computer programming. In addition to its mathematical applications, the representation of 2 as a quantity is also important in everyday life. For example, when we buy 2 items at a store, we are using the concept of 2 as a representation of quantity to count the number of items we are purchasing. Similarly, when we measure the length of an object in inches or centimeters, we are using the concept of quantity to determine the length of the object. The numerical value 2 can also be related to the concept of duality, where something has 2 aspects or components. This idea is prevalent across various fields of study. In philosophy, duality often refers to the concept of 2 opposing yet complementary forces or ideas, such as yin and yang in Taoism, or mind and body in Cartesian philosophy. These dualities represent fundamental aspects of existence and are often seen as essential for understanding the nature of reality. In literature and art, duality can manifest as contrasting themes, characters, or motifs. For example, a story might explore the duality of good and evil, or the contrast between appearance and reality. Duality can also be used to create tension or ambiguity in a narrative, or to highlight the complexity of human nature. In psychology, duality can refer to the 2 sides of a personality or the conflict between conscious and unconscious desires. For example, the concept of the ID, ego, and superego in Freudian psychology represents a duality of conflicting forces within the human psyche. Duality can also be seen in the contrast between rational and emotional thought processes. In computer science, duality appears in the concept of binary code, where information is represented using only 2 digits, 0 and 1. This duality is the foundation of digital computing and allows for the efficient storage and processing of information. Duality also plays a role in cryptography, where encryption algorithms use pairs of keys to secure data. In mathematics, duality can refer to the relationship between 2 mathematical objects or structures that are related in a certain way. For example, the concept of duality in linear programming involves finding the optimal solution to a primal problem and its corresponding dual problem. Duality can also be seen in the relationship between a vector space and its dual space. In physics, duality can refer to the wave-particle duality of light and matter, where particles can exhibit both wave-like and particle-like properties. This duality is a fundamental concept in quantum mechanics and has profound implications for our understanding of the nature of reality. Duality can also be seen in the concept of antimatter, which has the same mass as matter but opposite charge. In biology, duality can refer to the structure and function of DNA, which consists of 2 complementary strands that are intertwined to form a double helix. This duality is essential for the replication and transmission of genetic information. Duality can also be seen in the concept of symbiosis, where 2 different species live together in a mutually beneficial relationship. In economics, duality can refer to the relationship between supply and demand, which are 2 opposing forces that determine the price and quantity of goods and services in a market. Duality can also be seen in the contrast between microeconomics and macroeconomics, which study the behavior of individual economic agents and the economy as a whole, respectively. The value 2, as a number, can also symbolize relationships and connections. It represents the idea of partnership, cooperation, and balance between two entities. Consider the concept of teamwork, where two or more individuals work together towards a common goal. The success of a team often depends on the ability of its members to cooperate and communicate effectively, creating a synergistic relationship where the combined effort is greater than the sum of individual contributions. In social interactions, relationships are built upon mutual understanding, trust, and respect. The value 2 signifies the importance of these connections, as it represents the bond between two individuals. In a romantic partnership, for example, the success of the relationship depends on the ability of both partners to support each other, communicate openly, and share their lives together. In business, partnerships are often formed between two companies that have complementary strengths and resources. These partnerships can lead to increased market share, expanded product offerings, and greater overall success. The value 2 represents the potential for synergy and growth that can result from such collaborations. In nature, symbiotic relationships are common between different species. These relationships can take many forms, such as mutualism, where both species benefit, or commensalism, where one species benefits and the other is unaffected. The value 2 represents the interconnectedness of living organisms and the importance of these relationships for maintaining ecological balance. In mathematics, the concept of pairs is fundamental to many areas of study. A pair is a set of two elements, and it is the simplest type of set that can be formed. Pairs are used to define ordered pairs, which are used to represent points in a coordinate plane, and unordered pairs, which are used to represent sets of two elements. The value 2 represents the foundation upon which these mathematical concepts are built. In computer science, the concept of binary code is based on the value 2. Binary code uses only two digits, 0 and 1, to represent all data and instructions in a computer. The value 2 represents the fundamental building block of digital information, allowing computers to process and store vast amounts of data. In art and design, the concept of balance is often achieved through the use of symmetry. Symmetry involves the arrangement of elements in a composition such that they are equally distributed on either side of a central axis. The value 2 represents the equal distribution of elements, creating a sense of harmony and visual appeal. The number 2 is also deeply connected to symmetry, whether it's bilateral symmetry found in many living organisms or the concept of balance in various designs. Bilateral symmetry means that an object can be divided into two identical halves. This is evident in the human body, where the left and right sides are mirror images of each other. The concept of symmetry is also important in mathematics, where symmetrical shapes have properties that make them easier to analyze. In physics, symmetry plays a crucial role in understanding the laws of nature. Many fundamental laws of physics are based on the principle of symmetry, which states that the laws of physics should be the same regardless of the observer's point of view. In art and design, symmetry is used to create a sense of balance and harmony. Symmetrical compositions are often seen as more aesthetically pleasing than asymmetrical compositions. Symmetry can be achieved through various techniques such as mirroring, rotation, and reflection. The number 2, therefore, can be associated with balance, harmony, and the fundamental principles that govern the natural world. Understanding the meaning and significance of the numerical value 2 is essential for comprehending a wide range of concepts and phenomena across different disciplines.